Very good morning, my dear fourth semester mechanical and automobile students. Today I will solve two problems from the chapter Bernoullis Theorem. First of all, the question is like that. The water is flowing through a pipe having diameters 20 centimeter and 10 centimeter at sections 1 and 2 respectively. The rate of flow through the pipe is 35 liters per second. The section 1 is 6 meter above datum line and section 2 is 4 meter above datum line. If the pressure at section 1 is 39.24 Newton per centimeter square, find the intensity of pressure at section 2. First of all, question is like that. This is the datum line. This is the section 1. This is the section 2. At section 1, the diameter is 20 centimeter. 20 by 100 is equal to 0.2 meter. Area A1 is equal to pi by 4 is equal to pi by 4 into 0.2 square is equal to 0.0314 meter square. P1 intensity of pressure at section 1 39.24 Newton per centimeter square, or we can write as 39.24 Newton per 10 to the power minus 2 square, that is meter square, because 1 centimeter is equal to 10 to the minus 2 meter. 1 centimeter square is equal to 10 to the minus 2 square, that is 39.24 into Newton per 10 to the minus 4 meter square, or we can write as 39.24 into 10 to the 4, because this term is 10 to the minus 4 is equal to 10 to the 4 Newton per meter square. Z1 is equal to 6 meter. At section 2 is the section 2-2, D2 is equal to 10 centimeter is equal to 10 by 100 is equal to 0.1 meter. A2 is equal to pi by 4 D2 square is equal to pi by 4 into 0.1 square is equal to 0.00785 meter square. Here Z2 is equal to 4 meter. That is that the datum line is the Z1 is equal to 6 meter and Z2 is equal to 4 meter. P2 is equal to found out. We know that rate of flow Q is equal to 35 liters per second is equal to 35 by 1000 is equal to 0.035 meter cube per second, because 1 liter is equal to 1000 centimeter cube, or 1 liter is equal to 1 by 1000 meter cube. Therefore, 35 liters per second is equal to 35 by 1000 is equal to 0.035 meter cube per second. We know that Q, rate of flow, is equal to A1 V1 is equal to A2 V2. Therefore, V1 is equal to Q by A1. We know that Q is equal to 0.035 divided by 0.0314 is equal to 1.114 meter per second, because the unit of V1 is equal to meter per second. Or P2 V2 is equal to Q by A2 is equal to 0.035 divided by 0.00785 is equal to 4.456 meter per second. Applying Bernoullis equation at section 1 and 2, we have P1 by W plus V1 square by 2G plus Z1 is equal to P2 by W plus V2 square by 2G plus Z2. P1 by rho G plus V1 square by 2G plus Z1 is equal to P2 by rho G plus V2 square by 2G plus Z2, because small w is equal to rho G. Then putting all the values, we have P1 is equal to 39.24 into 10 to the power 4 divided by rho. Rho is equal to density for water is equal to 1000, G is equal to 9.81 plus velocity V1 1.114 square divided by 2 into 9.81 plus 6 is equal to P2 by 1000 into 9.81 plus 4.456 square divided by 2G, 2 into 9.81 plus 4, or 40 plus 0.063 plus 6 is equal to P2 by 1000 into 9.81 plus 1.012 plus 4, or 46.063 is equal to P2 by 1000 into 9.81 plus 5.012, or we can write as P2 by 1000 into 9.81 is equal to 46.063 minus 5.012 is equal to 41.051, or P2 is equal to 41.051 into 1000 into 9.81 is equal to 402710.3 Newton per centimeter square, or P2 is equal to 402710.3 divided by 10 to the 4 is equal to 40.27 Newton per cm square. You should carefully calculate, that is P2 is equal to 40.27 Newton per cm square. This is the required intensity of pressure at section 2-2. Then I will solve another problem. Now I will solve another problem. Water is flowing through a pipe having diameter 300 mm and 200 mm at the bottom and upper end respectively. The intensity of pressure at the bottom end is 24.525 Newton per cm square and the pressure at the upper end is 9.81 Newton per cm square. Determine the difference in datum head if the rate of flow through the pipe is 40 liters per second. Required diagram is the Z1 is equal to Z1 is the Z2. Now D1 is equal to 300 mm is equal to 300 divided by 1000 is equal to 0.3 meter, because 1 meter is equal to 1000 mm. P1 is equal to 24.525 Newton per centimeter square is equal to 24.525 into Newton divided by 10 to the minus 2 square, that is meter square, is equal to 24.525 into 10 to the 4 Newton per meter square. You should always remember that 1 centimeter is equal to 10 to the minus 2. 1 centimeter square is equal to 10 to the minus 2 square. Then A1 is equal to pi by 4 D1 square is equal to pi by 4 into 0.3 square is equal to 0.0707 meter square. At section 2, D2 is equal to 200 mm is equal to 200 divided by 1000 is equal to 0.2 meter. A2 is equal to pi by 4 D2 square is equal to pi by 4 into 0.2 square is equal to 0.0314 meter square. Now P2, here P2 is equal to 9.81 Newton per cm square is equal to 9.81 into Newton per 10 to the minus 2 square meter square is equal to 9.81 into 10 to the 4 Newton per meter square. Again, we know that Q is equal to rate of flow is equal to 40 liter per second, or 40 by 1000 is equal to 0.04 meter cube per second, because you should know that 1 liter is equal to 1000 centimeter cube, or 1 liter is equal to 1 by 1000 meter cube. Therefore, I am writing 40 by 1000 is equal to 0.04 meter cube per second. We know that Q is equal to A1 V1 is equal to A2 V2. Therefore, V1 is equal to Q by A1 is equal to 0.04 divided by 0.0707 is equal to 0.565 meter per second. V2 is equal to Q by A2 is equal to 0.04 divided by 0.0314 is equal to 1.274 meter per second. Applying Bernoullis equation at section 1 and 2, we have P1 by W plus V1 square by 2G plus Z1 is equal to P2 by W plus V2 square by 2G plus Z2. Or we can write as P1 by rho G plus V1 square by 2G plus Z1 is equal to P2 by rho G plus V2 square by 2G plus Z2, because small w is equal to rho into G. Then putting all the values, we have P1 is equal to 24.525 into 10 to the power 4 divided by 1000 into 9.81, because rho is equal to 1000, G is equal to 9.81, plus V1 0.565 square divided by 2 into 9.81 plus Z1 is equal to 9.81 into 10 to the 4 divided by 1000 into 9.81 plus V2 means 1.274 square divided by 2.2 into 9.81 plus Z2. Or after solving, 25 plus 0.0162 plus Z1 is equal to 10 plus 0.0827 plus Z2, or 25.016 plus Z1 is equal to 10.082 plus Z2. Or we can write as Z2 minus Z1 is equal to 25.016 minus 10.82 is equal to 14.19 meter. Therefore, the required difference in datum head is equal to Z2 minus Z1 is equal to 14.19 meter. Thank you.